Hello, my name is Gary Patty. I am the CSO of Panome Bio, and I'm here for ChatGJP. The question is, what are some of the most exciting advances in metabolomics that are happening now? So metabolomics has been around really for a couple of decades now. At least the idea of measuring the metabolome has been around for a couple of decades. Obviously, scientists have been using analytical technologies to profile metabolites for much longer, for centuries really. But at least the idea of trying to measure as many metabolites as possible from a biological system has been an effort that's been underway now for 20 years or more. So the question is, in that spirit, we're trying to measure as many metabolites as possible. What's some of the most exciting advances that are happening? Well, I'll start by saying that there really have been profound transformations in the field over the last decade or so. And those have to do with expansions in databases that allow us to identify more metabolites. They have to do with the development of new hardware. So that would be new technologies, new mass spectrometers that are able to collect data faster. They're able to collect data more robustly, more consistently, and they're able to be more sensitive, meaning that we don't have to use as many samples. But I would say most impressively have probably been the developments in the software development space. So over the last few years, we've seen an amazing amount of improvements in our ability, not so much to collect metabolomics data, but trying to figure out what to do with the metabolomics data that we collect. It's actually relatively straightforward to generate the metabolomics data. I think the real challenges are trying to figure out how to interpret it in the context of biochemistry, metabolic pathways, in other omics. And so we've developed a lot of tools for that over the last few years that one, allow us to make more identifications. I already alluded to that because we have better databases and better prediction tools. But also to try to integrate those metabolomics data with other omics technologies like proteomics or even gene sequencing, as well as our ability to support more complicated experimental designs. So not just do we have sick people and healthy people, or two classes, but do we have class A and class B and class C and class D, and we want to know what's up in A but down in D, but down in all these different complex patterns. Or we can do things like time courses. If we do a longitudinal analysis, so perhaps we're going to track a biological system for several days and make metabolic measurements and try to understand how bioinformatically what metabolites are changing different periods. Do they correspond with circadian rhythm? Making these sorts of deductions from the data. And that's, I think, where the software has just progressed enormously over the last few years and have really allowed us to extend our ability to interpret the data.